Okay, question 3. Find the relative maximum point and the relative minimum using the first derivative test. Fx here equals to the 4x cubed plus 15x squared minus 18x plus 7. Okay, given the cubic function, fx equals to the 4x cubed plus 15x squared minus 18x plus 7. So first you find the first derivative, differentiate y with respect to x. F prime of x here equals to the 12x squared plus 30x minus 18. Okay, and the stationary point of this cubic function defined when the first derivative here equal to 0. So you let the first derivative f prime of x here equal to 0. 12x squared plus 30x minus 18 and here equal to the 0. Yeah, and move out the constant 6 times 2x squared plus 5x minus 3 and equal to 0. And you factorize the quadratic function, 2x minus 1 times x plus 3 times 6 and equal to 0. And then you find the value of x. X here equals to the 1 over 2 and x equals to the negative 3. Okay, step 2, you draw the table of a shape of tangent. Table with the 4 columns and 3 rows. First row here you put the value of x. Okay, and the second row you put the first derivative f prime of x, and the third row here shape of tangent s or t, and the first value of x here equals to the 1 over 2. Okay, and you put the value of x at the center of the tables. You put here x equals to the 1 over 2. And from the left of the function, between negative infinity to x equals to the 1 over 2, the nearest value here, x equals to the 0. Okay, you pick the nearest value, and you substitute this value into the first derivative. Okay, you substitute the 0 here into the first derivative, and the first derivative equals to the 12x squared plus 30x minus 18, and you substitute 0, and first derivative here equals to the negative 18. So sign of the first derivative, negative 18, this one you pick the negative sign. Yeah. So the first value here when x here equal to 0, and the sign of the first derivative negative. So here you put the negative sign. Okay. And the third row, shape of tangent. So shape of tangent, when the sign here Okay, shape of tangent when the sign of the first derivative negative, so gradient here decrease, and sign here positive, so here you put the increase, and then when the first derivative here equal to 0, so you draw the horizontal line. Yeah, and when x here equal to 0, first derivative here equals to the negative, so here the shape of tangent decrease, so you draw the shape of tangent. Okay, and the second value when x here equals to the 1 over 2. Okay, and you substitute into the first derivative. This substitution you just use your calculator. Okay, x here equals to the 1 over 2, and then the first derivative here equal to the 0. Okay, and here you put the horizontal line. Okay, and the third column, the nearest value after 1 over 2 here, x equals to the 1. Yeah, and here substitute into the first derivative, and the sign here positive. Okay, and the shape of tangent here increase. Okay, when you combine the three shape of tangent from the left here, decrease, horizontal line increase, so the stationary point here with the relatives minimum point. Okay, settle the shape of tangent, and then when x here equals to the 1 over 2, and you substitute into the cubic function fx, so the value of y here equals to the 9 over 4. Yeah, and 1 over 2, 9 over 4 is the relatives minimum point. Okay, the second value of x here equals to the negative 3. So from the left of the function, negative 4, the nearest value, and x here equals to the negative 2. So you substitute negative 4 into the first derivative, and the sign here positive, and the shape of tangent here increase. Negative 3, you substitute into the f prime of x here equal to 0, and then you draw the horizontal line, and the third value negative 2, and first derivative here negative, and you draw the shape of tangent decrease. Yeah, and you combine from the left here increase, horizontal, and decrease, so graph stationary point here with the relatives maximum point. Okay, and you substitute negative 3 into the function, so the fx here equals to the 88, and the negative 3, 88 is the relatives maximum point. Okay, first here, when the shape of tangent from the left here increase, horizontal line decrease, so the shape here with the stationary point of the function with the relative maximum point, yeah. And here decrease, horizontal increase, so you draw the shape of tangent with the relative minimum point, number 2. So first, number 1 and number 2 here, stationary point of the function exists with the relative maximum and the relative minimum point, okay. Number 3, graph here increase, horizontal and increase, so when you combine this one, the graph of the cubic function, so the stationary point of the function here does not exist, okay, no minimums, no maximum point. And number 4, decrease, horizontal and decrease, so you combine this one, the graph of the cubic function, and the stationary point of this function does not exist, yeah. Okay, question 4, find the intervals where fx equals to the 1 over 3x cubed minus 4x plus 2 is increasing and decreasing. Okay, first fx equals to the 1 over 3x cubed minus 4x plus 2. So you first find the first derivative of the function. F prime of x here equals to the x squared minus 4. And you let the first derivative here equal to 0. X squared minus 4 equal to 0. And then you factorize the quadratic function. X minus 2 times x minus 2. This one is plus 2. Okay, and equal to 0, and you find the value of x here equals to the plus minus 2. Okay, so you draw the table. First row here, you put the interval of the function, and the second row, the first derivative, f prime of x, and the third row here, the function increase or decrease. Okay, first the interval of the cubic function. So the value of x here equals to the plus minus 2. Okay, so you draw the number line. So graph of the cubic function, domain of the cubic function here is all the real numbers. So the f here is all the real numbers between negative infinity to the positive infinity. Yeah. So the first value from the left, negative 2, and here x here equals 2. Yeah. And the first value of first interval between negative infinity and negative 2. This one from the left here, negative infinity to the positive infinity. So the first interval you write down here from the left, negative infinity, negative 2, and the second intervals between negative 2, 2, and the third interval here 2 to the positive infinity. Yeah. Okay, and first row here you put the interval of the cubic function, negative infinity, negative 2, first interval, second interval, negative 2, 2, and third interval here 2 to the positive infinity. Yeah. Okay, between negative infinity and negative 3, you pick the nearest value. Yeah, the nearest value after -2, this one the -3. Yeah. Okay, when x here equals to the -3, so you substitute into the first derivative, and the first derivative here equals to the 5. Yeah, and then sign here positive. Okay, so the second row here you put the positive sign, and then the fx here positive, so the sign here increase, you put the inc. Yeah, when the sign here positive, you put the gradient of tangent increase, inc. When the sign of the first derivative here negative, so here you put the dec, decrease. Yeah, and the second value, when x here equals between -2 and 2, maybe here you pick the x here equal to the 0. Yeah, and then x equal to 0, you substitute into the first derivative. This one you just using the calculator. Okay, x equal to 0, and then the sign here equals to the negative. Okay, and then fx here decrease, and then number 3, between 2 to the positive infinity, after 2 here the nearest value x equals 3, and then you substitute into the first derivative, and the sign of the first derivative here positive, and the fx here increase. Yeah. Okay, and the answer, fx here increase in the interval -infinity, -2, and 2 to the positive infinity. And the second, fx decrease in the interval -2 to 2.